So today we're going to analyze some aggregate. This material is granular A, is road-based aggregate, and normally this material will have come from the field, from a stockpile where you actually sample in a representative manner of the material, and then you bring it to the lab, and this could be in a 5-gallon bucket or something. The procedure of quartering is basically carefully dropping it in and splitting the sample in halves. So when you look at this quartering device, half will go on tray and half will go to the other tray. We will discard part of it and repeat the process. But again, we're going to quarter that or cut it in half one more time. Once this procedure is completed, then we're dealing with a smaller amount of material. In our testing, we assemble a series of sieves ranging from the 1-inch to the number 200 sieve. And in the description of the sieves, when we talk about numbering, the number 200 will mean that there's 200 of these openings in a linear inch. We have the stack of sieves ready to go. And the procedure now is to carefully inspect each one of these sieves for damage. There could be a tear on the material, there could be material stuck on it from previous use, so you want to make sure that you start with proper sieves, and at that point you're ready to pass through the material through the series of sieves. The sieves have been arranged in an order from largest opening to smallest opening, and at the bottom there's a solid lid or a pan at the bottom that will collect the material passing through all of them. We put a lid on it and we're ready for the next step, which is to put it in the shaker. This is set up for 5 minutes so that when we press start, we start shaking the material continuously for 5 minutes. Once the shaking process is completed, we retrieve the series of sieves from here, from the shaker, and we bring it back to our weighing station. So at this point we're going to dismantle this setup, and individually, sieve by sieve, we're going to weigh how much material was retained individually in the sieves. So the first thing is to tear the scale, so we start with a 0, and we go one by one. This is the 1-inch sieve that all the material passed through because it's granular A material, and that's the specification. We go to the next sieve and we have the particles that have been, so that number will be recorded and accounted for. We can either 0 tear your material again, the scale again, and then continue going to the next one. Each time that you do this process, it's very important to make sure that all the material, some of the material will be stuck into the sieve, but it's very important that it all comes out and it gets accounted for to the right sieve size. As we go through each sieve, we're dealing with different quantities of materials, and you're going to see more and more the need to be careful when you retrieve the sample. So again, 0, and very carefully pour it. And again, there's material stuck to it, which with the aid of a brush, we're going to ensure that there's no material left in. So this would be the new weight corresponding to the particular sieve that we're dealing with. And typically the last sieve would be the number 200 in a standard. So after recording the amount retained in the 100 with 0, clear the scale, and we bring in the number 200 sieve. As we get finer, it's more critical that you are careful in minimizing the amount of dust and also ensuring that all the material, as much as practicable, has been removed from the sieves. This is sieve number 200, which means that there's 200 openings per linear inch, and that would leave us to a size of 75 microns. Or 0.075 millimeters is the actual size of the opening. Sieve number 200. The material that went through the number 200 is accumulated in the pan. And that material will be what is known as the fines, the content of fines in the soil, which includes silt and clay material. As you can see, it's a powder. You don't feel the grittiness because it's like a talc, it's like a powder material, and what this will be telling you is that it's material that is particles that are smaller than 0.075 millimeters, or in other words, particles that pass through the number 200 sieve. When we complete the experiment, now we're going to have a total weight of the sample, which will add up very closely to the number that we started with. And we're going to illustrate that in our calculation spreadsheet or when you do a manual calculation.